You see it in the photographs now. Green coma, blue tail bent by solar wind, dust trailing in the opposite direction. December 5th, 2025, and the images are flooding in from Texas, from Chile, from observatories scattered across 3 continents. 3I Atlas, the third confirmed visitor from another star system. Not ours, not bound to our sun, just passing through. And what these first Earthside tail shots reveal changes everything we thought we understood about where it came from and what it means to be a comet. Speed, 221,000 kilometers per hour. But the numbers told a different story. Hyperbolic trajectory, not elliptical, not bound. When astronomers traced the path backward through space and time, it pointed to interstellar origin, direction, Sagittarius, near the Milky Way's core. The Minor Planet Center got 122 observations from 31 observatories in those first hours. Pre-discovery images turned up fast. Zwicky Transient Facility had it June 28th and 29th, then June 14th through 21st. Atlas Archives showed it June 5th through 29th. The comet had been there all along, hidden against the galaxy's bright heart, where faint objects disappear in stellar noise. Lowell Discovery Telescope in Arizona, Canada-France Hawaii Telescope on Mauna Kea. All showed a marginal coma with tail-like elongation 3 arcseconds long. David Jewett and Jane Liu at the Nordic Optical Telescope on July 2nd, clearly active with diffuse appearance. The reddish color of the coma matched dust composition, similar to 2I Borisov, the second interstellar visitor from 2019. But 3I Atlas was different, bigger, more active, and carrying chemistry that made no sense. Latest edits from December 5th, 2025, the European Space Agency's 3I Atlas, frequently asked questions. Page, the astronomy picture of the day from December 1st, 2025, by NASA, featuring 3I Atlas tails captured from Texas, peer-reviewed arcs of preprint papers on 3I Atlas chemical composition from August 21st, 2025, and the Minor Planet Center's official discovery announcement from July 2nd, 2025. These are primary sources, space agency documentation, telescope observation databases, and direct scientific measurements, not aggregated news summaries. Now back to the information. The nucleus, somewhere between 440 meters and 5.6 kilometers in diameter. The uncertainty comes from brightness and distance calculations. Observations through August 20th narrowed it down, but couldn't pin exact size. Too far, too faint. Background stars streaked across the exposure because Hubble tracked the comet's hyperbolic motion. Not circular, not returning. One pass through our system and gone forever. The James Webb Space Telescope turned its near-infrared spectrograph on 3. To I Atlas, August 6th, 2025. Distance from Sun, 3.3 astronomical units. Water ice shouldn't sublimate at that range. Too cold. But 3I Atlas was active anyway. The spectrograph revealed carbon dioxide dominating the coma, 8 times more carbon dioxide than water, ratio unprecedented for solar system comets. Our comets release water first. Water drives their activity. 3I Atlas flipped the script. Carbon dioxide led. Water followed weak. Carbon monoxide appeared in moderate levels. Hydroxyl radicals confirmed water vapor, but at concentrations far below normal. The chemistry screamed cold formation environment, colder than our outer solar system, colder than the regions where our comets condensed 4.6 billion years ago. Very Large Telescope in Chile tracked nickel vapor from July through August 2025. Distance, 4.4 astronomical units to 2.85. Nickel emission increased rapidly and steadily, 4.6 grams per second, plus or minus 0.7 by August 21st. Cyanide followed at 17.6 grams per second, plus or minus 2. The nickel appeared before cyanide, unusual but not unprecedented. Solar system comets show both at similar distances from the Sun. But 3I Atlas had another puzzle. Strong nickel, weak iron. Nickel and iron usually appear together in roughly solar proportions, released from organometallic compounds that sublime at low temperatures. 3I Atlas showed the imbalance clearly in early measurements. The ratio began normalizing as the comet approached the Sun, suggesting temperature-dependent release or different chemical pathways in its original ices. Older than the Sun, older than the solar system itself. A relic from when the galaxy was young and star formation peaked. Cosmic noon, the thick disk hypothesis matched the chemistry. Low iron relative to alpha elements, high carbon dioxide, preserved volatiles from an era when galactic conditions differed sharply from today. MAVEN mission captured hydrogen atoms around 3, Dagmar Atlas, September 28th, 30 million kilometers out. Perseverance rover spotted it. October 4th as a faint glow, proof that surface observers on another world could see an interstellar visitor. Mars Reconnaissance Orbiter and ExoMars. Trace Gas Orbiter both imaged it between October 1st and 7th. The CASIS instrument on Trace Gas Orbiter pointed away from Mars' surface for the first time, aimed at the distant comet sweeping across a starry backdrop. The resulting astrometric measurements became the first spacecraft data from another planet's orbit officially submitted to the Minor Planet Center database. The observations refined 3I Atlas position by a factor of 10, critical for trajectory predictions. Valuable rehearsal for planetary defense protocols, even though 3I Atlas posed zero threat. Solar conjunction on October 21st had already made ground observations impossible. Only space-based instruments could watch. SOHO's LASCO coronagraph tracked it, October 15th through 26th. Parker Solar Probe caught glimpses. Stereo mission captured stacked, colorized images, showing the tail as a short elongation. Lucy spacecraft spotted it from 240 million miles away on its way to the Trojan asteroids. Psyche spacecraft made 4 observations over 8 hours. September 4th, passing within 0.302 astronomical units, 45 million kilometers. Sphere-X mission observed for about a week. Punch collected combined images. September 20th through October 3rd showing tail development. Europa Clipper sailed through the predicted ion tail zone October 30th through November 6th. Magnetic draping structures should appear in the solar wind data when it's analyzed. Hera spacecraft potentially immersed in the tail October 25th through November 1st. Main high-gain antenna serving as heat shield. Data transmission throttled to the smaller medium-gain antenna. The spacecraft on the far side of the Sun from Earth. Full scientific data won't arrive until February 2026. The team couldn't wait. They downloaded a 1/4 navigation camera image taken November 2nd. Low resolution, partial frame, but enough. The comet clearly visible, bright coma, 2 distinct tails. Plasma tail of ionized gas stretching upward, fainter dust tail of solid particles trailing lower left. Scientists surprised by how active 3I Atlas looked so soon after perihelion. The image leaked December 4th, 2025, generating immediate media coverage worldwide. The tail shots flooding in show structure ground telescopes couldn't resolve in July and August. The ion tail, blue-tinted, wandering, deflected by solar wind. Classic cometary behavior. The dust tail, separate trajectory, following orbital mechanics as solar radiation pressure pushes smaller particles faster than larger ones. The anti-tail, slight, pointing toward the sun, an optical illusion created by viewing geometry as Earth sees dust. Particles spread along the comet's orbital plane. All 3 tails visible in the Texas image from late November, captured for the astronomy picture of the day December 1st. Green coma from diatomic carbon fluorescing in sunlight. Typical? Normal? Exactly what solar system comets do. Years ago, in a different galactic environment. The chemical composition differs. Carbon dioxide heavy, water light, nickel without iron at first, but the physics remains identical. Sublimation, outgassing, tail formation, coma structure, solar wind interaction, the green color, the blue ion tail, the dust following orbital paths. 3I Atlas confirms our solar system isn't special. The processes that built our comets operate elsewhere. The volatile ices form under different conditions, but respond to stellar heating the same way. Our planetary system, typical. Our star, typical. Our formation history, one example among countless billions playing out across the galaxy's spiral arms. Gemini North Observatory in Hawaii tracked it through real-time observation sessions, broadcast for Shadow the Scientists seminars. Ground-based telescopes in Chile at Gemini South showed tail growth to 30 arcseconds in August. Keck Observatory in Hawaii identified depleted organic carbon compared to solar comets. Over 50 analyzed solar comets provide the baseline. 3I Atlas stands out, but not wildly. The differences matter for formation environment reconstruction. The similarities matter more for understanding planetary system universality. The comet already receding from the sun, losing activity, dimming, magnitude hovering near 10 to 11, visible through telescopes with 30 centimeter aperture or larger. Binoculars might show it under dark skies for experienced observers. Amateur astronomy clubs hosting viewing events, observatories opening to the public. Final chance to see an interstellar comet before it fades beyond reach. The trajectory carries it past Jupiter March 16, 2026. Distance, 0.358 astronomical units, 53.6 million kilometers, then out, beyond the heliopause, back to interstellar space at 50 to 60 kilometers per second. Same speed it arrived. Gravity adds energy on approach, subtracts it on departure. The comet will spend millions of years drifting through the galaxy's disk before encountering another star system. Maybe it will survive that encounter. Maybe it will fragment. Maybe it will be captured into orbit. Maybe it will pass through like it passed through ours and continue the journey without end. They accumulate ices based on local temperature and pressure. They get ejected by gravitational interactions with massive bodies, gas giants, stellar companions, passing stars. They drift through interstellar space for billions of years. Cosmic radiation alters surface chemistry. Interstellar medium strips outer layers. Time changes them, but doesn't erase their origin. When they dive into another system, solar heating sublimates their volatiles exactly like it sublimates the volatiles of comets born here. The tails form. The coma brightens. The nucleus sheds dust and gas. Physics universal. The dust tail shaped by radiation pressure and orbital mechanics. The green coma from carbon molecules excited by ultraviolet light. The antitail appearing when viewing angle aligns with the orbital plane. Everything predicted, everything expected. Everything normal for a comet, despite its interstellar origin. Carbon dioxide dominance suggests the protoplanetary disk where 3I Atlas condensed had stronger carbon dioxide ice line. Cold outer regions where carbon dioxide freezes before water. Our solar system has a carbon dioxide line, but it's subtle. Water dominates. Because the sun's luminosity and temperature created conditions favoring water ice accumulation in the comet forming zones. 3I Atlas formed around a different star. Lower luminosity possibly, different temperature gradient, different volatile condensation sequence. The high carbon dioxide locked in when the comet was young remains detectable now billions of years later. Radiation can alter mineral inclusions. It can create new chemical pathways. It can change which volatiles sublime first when the comet finally encounters stellar heating again. The evolving nickel-iron ratio, as 3I Atlas approached the sun, supports temperature-dependent release. Warm the nucleus, and iron-bearing compounds start sublimating, normalizing the ratio towards solar system values. The polarimetric observations from July and August by Very Large Telescope, Nordic Optical Telescope, and Rosen Observatory revealed unusually high negative polarization at small phase angles. Light reflected from the coma had oscillations oriented along the Sun-Comet observer plane more than typical comets. The polarization signature matched trans-Neptunian objects, mixture of icy and dark material, preserved surface properties from the object's formation or from interstellar processing. Either way, evidence of conditions different from the warm inner solar system where most cometary observations happen. Reddish color indicates silicate-rich dust. As outer volatile layers boiled away, deeper material emerged carrying different composition. The color shift documented the transition. Solar system comets do this too, but over different timescales with different starting compositions. 3I Atlas provided comparison data. 3 astronomical units from the Sun. Rate, 1.5 times 10 to the 25th power molecules per second, plus or minus 0.5. 1 week later, September 14th, the rate climbed to 4.5 times 10 to the 25th power, plus or minus 1.9, 2 kilograms per second. Hydrogen cyanide is a standard cometary volatile. The increasing production rate matched decreasing solar distance, normal behavior. Expected outgassing response to heating, 3I Atlas following the pattern. The images showed slight coma diameter increase and provided nucleus diameter constraints. If Rubin had started validation 2 weeks earlier, it would have discovered 3I Atlas before Atlas did. The comet was there, bright enough. Just needed someone looking in the right direction at the right time. The comet appeared on multiple nights, but wasn't flagged as interesting. Dense star fields, galactic center region, object motion subtle against the crowded background. Detection algorithms tuned for near-Earth asteroids might miss slow-moving outer system objects blending with stars. Human review could have caught it earlier, but human review can't examine every image from every telescope every night. Automated systems filter. Sometimes they filter out gold. Professional observatories can track it through the winter into spring 2026, but casual viewing ends this month. 1I Oumuamua showed no activity at all, possibly because it was too small to retain volatiles or had already lost them in previous stellar encounters. 3I Atlas remains intact. Stable nucleus, steady outgassing, predictable behavior. The gravitational stress of perihelion didn't crack it. Solar heating didn't explode it. It's surviving the passage. Tensile properties of interstellar cometary material. If 3I Atlas formed 7 to 14 billion years ago and spent most of that time in cold interstellar space, its ices should be pristine, unmelted, never heated until this solar system encounter. The nucleus strength during perihelion confirms the object isn't a rubble pile. It's a coherent body, probably sintered together by billions of years of cosmic ray processing, creating chemical bonds between grains, possibly reinforced by amorphous ice transitioning to crystalline states under solar heating, releasing latent heat and gas that welds the structure tighter rather than blowing it apart. When gas jets spray from the nucleus, they push like tiny rocket engines. The thrust changes the orbit slightly, measurable, predictable once you know the mass and gas production rate. 3I Atlas shows these perturbations. Small, compatible with observed activity levels, nothing anomalous. Some early speculation suggested non-gravitational acceleration might indicate that something unusual, artificial propulsion, directed jets, structural anomalies. But the numbers fit standard outgassing models. The comet accelerates exactly how a comet should when its nucleus sublimates asymmetrically. Trajectory aligned with the ecliptic plane. Follow-up observations demolish those claims. Size range narrows to sub-kilometer to few kilometers. Chemicals identified extensively: carbon dioxide, water, carbon monoxide, cyanide, nickel, hydroxyl. Trajectory not particularly aligned with ecliptic. 175 degrees inclination means retrograde and 5 degrees off the plane, similar to many long-period comets. The paper got media attention. The science didn't support it. Loeb's claims about withheld information and missed opportunities don't match the extensive observational campaign documented by NASA, ESA, and international collaborators, publishing results throughout the encounter. Traveling through space for billions of years, heated by our sun, releasing gas and dust, growing tails shaped by physics, behaving exactly how comets behave because it is a comet, and physics doesn't care about origin. Ground-based instruments can track activity evolution. Spacecraft throughout the solar system can provide multiple viewing angles. Mars orbiters can refine trajectories. Planetary defense protocols can practice with low-risk visitors. The network functions. When the next interstellar object appears, and statistical models suggest one every decade or two, we'll be ready. 2. I. Borisov, August 2019. 3I Atlas, July 2025. Detection rate increasing, but that's observation bias. Surveys improving. Telescope networks expanding. Vera Rubin coming fully online will catch fainter, more distant objects earlier. Atlas expanding. ZTF scanning nightly. Multiple automated systems combing the sky. We're not seeing more interstellar visitors. We're finally seeing the visitors that were always passing through unnoticed. 2nd 2025, Smithsonian Magazine's article titled "Telescopes Reveal Surprising Chemistry of a Rare Interstellar Object Passing Through Our Solar System." From August 28, 2025, the Archive preprint paper titled "3I Atlas Direct Spacecraft. Exploration of a Possible Relic of Planetary Formation at Cosmic Noon from August 21st, 2025, by multiple institutional authors, including detailed spacecraft observation predictions and chemical composition analyses, and NASA Science's What's Up, December 2025. Skywatching Tips, page published December 1st, 2025. Back to the comet. The December 19th closest approach is a measurement point. Astronomers worldwide will take photometry, spectroscopy, polarimetry. Every data point refines the model. Every spectrum adds chemical information. Webb's next observations, scheduled for December post-perihelion, should reveal how the coma chemistry changed as the comet receded from peak heating. The JUICE data, arriving February 2026, will show the comet at peak activity from a non-Earth vantage point. Different viewing angle. The 5 instruments will provide 3D reconstruction when combined with Earth-based observations. Europa Clipper's potential tail crossing means direct sampling if instruments detected anything. Data processing takes months. Astronomers will monitor 3I Atlas as long as it remains visible. Eventually it will fade beyond detection. Then it's gone from our view, traveling through the galaxy's disk, silent, dark, cold. Proof amateur and professional equipment captures the same phenomena. Solar ultraviolet light excites electrons in the carbon bonds. The electrons drop back to lower energy states, emitting green photons at 517 nanometers wavelength. Every comet with organic carbon shows this. 3I Atlas is no exception. The blue ion tail comes from ionized carbon monoxide, CO+. Solar wind and magnetic fields push the ions directly away from the sun. The dust tail comes from solid particles released from the nucleus following orbital mechanics. Larger particles lag behind. Smaller particles get pushed harder by radiation pressure. The tail curves. The colors separate. Blue ions. Whitish dust. Green coma. Standard comet structure seen in every active comet since humans first pointed telescopes skyward. The comet sheds particles continuously. Those particles spread along the orbital path. When Earth's position aligns with the orbital plane, we see the spread out particles extending both away from and toward the sun. Optical illusion, geometric effect, happens with solar system comets regularly. The December viewing geometry for 3I Atlas creates this alignment. The Earthside observations capture it perfectly, short, faint, pointing sunward. Exactly as predicted. When magnetic field orientation shifts, the tail bends, all these effects observable if someone is watching every night. Time-lapse sequences will reveal the dance between the comet and the sun's extended atmosphere. December through January 2026 offers the window. Every clear night, someone somewhere will image 3I Atlas. Personal connection to cosmic scale. Study them comprehensively. 3I Atlas won't be the last. Each one a messenger from another system, each one responding to our sun's heating because physics is universal. They get kicked out by gravitational perturbations. They drift through interstellar space. They occasionally encounter other star systems. When they do, solar heating sublimates their ices, radiation pressure shapes their tails, and magnetic fields sculpt their ion distributions. Everything predictable, everything understandable, everything natural. Nothing less. That's the revelation. The universe isn't full of mysteries that require exotic explanations. It's full of natural processes operating consistently across time and space. 3. I Atlas, formed billions of years ago around a star we'll never identify in a region we'll never visit, but the physics that formed it matches the physics that formed our comets. The chemistry differs in details, but not in kind. The structure responds to heating like our comets respond. The tails form like our comet tails form. Same universe, same laws, same outcomes. All seeing the same object, all measuring consistent properties, all confirming the models. The comet is exactly what it appears to be. The explanations require no mysteries. The observations match predictions. The science works. 2I Borisov was studied intensively but with less infrastructure. 1I Oumuamua was barely studied at all, discovered after perihelion, already outbound, non-active or barely active, gone before serious campaigns began. 3I Atlas benefits from lessons learned. Early detection, long observation baseline, multiple spacecraft positioned throughout the system, international coordination, planned campaigns with major facilities. The data will feed models for decades. If we know it's coming, if we have spacecraft waiting, if the Delta V budget works, we could send a probe to flyby or even rendezvous. Sample return mission remains distant dream but flyby with close-up imaging and in situ measurement. That's achievable with current technology and advance warning. Every spectrum tells what instruments to bring. Every image shows what features matter. When we finally get close to an interstellar object, we'll know what questions to ask because 3I Atlas taught us what's typical and what's unique. What's unique? Carbon dioxide dominance, nickel-iron imbalance, age estimates, thick disk origin hypothesis, pristine preservation of ancient chemistry. Typical and unique together paint the picture. Solar system comets vary too. Short-period Jupiter family comets differ from long-period Oort cloud comets. Pristine bodies differ from thermally processed ones. 3I Atlas adds one more data point. Extreme case. Outlier in origin, but mainstream in behavior. Proof that international collaboration works. Proof that citizen science contributes. Amateur astronomers capturing images NASA uses. University students analyzing spectra professionals review. High school telescope clubs hosting viewing events that inspire the next generation. Visible through 6-inch telescopes and larger under dark skies. Tail extending roughly 0.7 degrees. Multiple structure visible. Ion tail, dust tail, anti-tail. Green coma bright. Nucleus stable. Outgassing steady. Trajectory precisely known thanks to ExoMars. Trace gas orbiter's Mars orbit observations, refining position to 10 times better accuracy. Closest Earth approach 14 days away, December 19th, Friday morning. Pre-dawn eastern sky, final best chance. Should, multiple observers, multiple techniques, multiple perspectives converging on comprehensive understanding. By magnitude 25, invisible even to Vera Rubin, somewhere in late 2027 or 2028, the last detection, then silence. 3I Atlas continues outward, back to interstellar space, back to darkness, back to cold, carrying with it the subtle changes our sun imposed. Slight mass loss from sublimation, altered surface chemistry from heating, modified rotation from outgassing jets. Permanent marks from temporary encounter. Or it might drift through empty space for the galaxy's remaining lifetime. We can't predict. We can only document the moment when its path intersected ours, and our sun heated its ancient ice and our telescopes captured the light. The images will outlast us. The data will remain valid. The measurements will serve as benchmark. This is what an interstellar comet looks like when it visits a main sequence G-type star at this distance, at this activity level, with this composition. Reference point. Comparison standard. Foundational knowledge for the field. Traveling naturally, behaving naturally, responding to our sun's influence naturally. Everything about it fits natural explanations. The unusual chemistry, formation, environment, the extreme age, thick disk origin, the high activity, carbon dioxide driven sublimation, and the stable nucleus, billions of years of cold sintering, Typical tales, universal physics, nothing mysterious, nothing exotic, nothing requiring revision of our understanding of how comets work, or where they come from, or what happens when they travel between stars. March 1620-26. Jupiter passage predicted accurate to kilometers. Future sky positions calculated years in advance. When it fades from view, we'll still know where it is. Trajectory locked in, memory preserved. The comet might be invisible, but it's not unknown. We measured it. We understood it. We documented everything it did during its months in our system. The position on December 19th at closest approach, right ascension 12 hours, 14 minutes, declination plus 11 degrees in eastern Leo, 3 degrees south of Regulus. Distance 1.798 AU, velocity 68,000 kilometers per hour relative to Earth, 150,000 relative to the Sun. Magnitude 10 to 11, tail length approximately 1 degree. Coma diameter approximately 8 arc minutes. Everything specified, everything measured, everything known to available precision. When future astronomers ask what 3I Atlas looked like at closest approach, the data answers completely. The dataset will serve science for decades. When 4I arrives, we'll have 3I Atlas as template. When 5I appears, we'll know what worked and what needs improvement. Each visitor teaches, each encounter refines technique. Each opportunity exploited fully prepares for the next. The moment when Earth-based observers have the best view. Before it came around perihelion, we watched from behind, seeing the tail foreshortened. After perihelion, we watched from ahead, seeing the tail streaming back. December geometry optimal, full tail structure visible, coma bright against dark sky, background stars, providing astrometric reference, everything aligning for maximum science return. These images will define 3I Atlas in public memory. Not the technical data, not the spectroscopic measurements, not the orbital elements. The images, green comet with blue tail against star field. Simple, beautiful, understandable. That's what people will remember. That's what will appear in textbooks decades from now when students study interstellar visitors. Chapter heading, 3I Atlas. Image, December 2025, Earthside tail shot. Caption, interstellar comet at closest approach showing typical cometary structure. Standard example. Reference case. The comet that proved interstellar visitors behave like local comets because physics doesn't depend on birth location. Coma with 2 distinct tails. The surprise wasn't that the comet showed activity. The surprise was how clearly the activity appeared in low-resolution partial frame navigation, camera image never intended for science. Even crude observations reveal the obvious when the object is bright enough and active enough. 3I Atlas cooperated. It brightened on schedule. It developed tails as predicted. It remained visible when expected. No surprises. No failures, no disappointments. Everything worked because everything followed physical law, and physical law is reliable. This is what we see. The interstellar aspect adds interest but doesn't change fundamentals. Marcus noted the comet's survival through perihelion indicates structural integrity. Graykowski noted the chemistry indicates formation conditions. Both agreed 3I Atlas represents natural object following natural processes. No exotic explanations needed, no mysteries remaining. Just one more comet, better documented than most because its origin makes it special even though its behavior doesn't. Outgassing, the predictable orbit, all consistent with natural cometary behavior. No anomalies, no mysteries, no exotic features requiring new physics or unprecedented explanations. Just a very old comet on a very long journey briefly visiting our neighborhood before continuing into the galactic dark. Simple, natural, understood. That's the revelation. Not that the universe is stranger than we thought. That it's exactly as strange as we calculated it should be, and that's strange enough. Typical. The chemical composition broadly similar. The ejected dust broadly similar. The tail formation and structure broadly similar. The differences matter for detailed formation models. The similarities matter for understanding universal planetary system processes. Both important, both documented, both preserved in December's Earthside observations that captured the comet in its brief moment of maximum visibility from Earth before it fades, forever into the depths from which it came.